Hi, this screencast is a quick demo of my final year project. It's called HEXplorer, and it's a platform that lets you benchmark homomorphic encryptions, which basically means running AI on data that's never decrypted. So what you are looking at right now is HEXplorer is running live, and the front end is hosted on Vercel, and behind the scenes there's an AWS EC2 server doing the heavy computations. You don't need to install anything. You don't need to touch a terminal. You just open a browser and you are running real encrypted AI. And sometimes people will think this doesn't affect me, but every time we use an AI service, your data gets sent to a server, the name, the problem, the private situations, and that message gets sent to a server, and that server has to open your data to do anything with it. But homomorphic encryption changes that. The AI runs on your data while it's still locked. The servers never sees it. So my platform is let you watch this happen live and see exactly how much it costs. So first at the top, there's a small animated tutorial. The out here walks you through what homomorphic encryption is step by step before you touch anything. When people read this, they can understand what's about to happen. And below that, the workbench, this is where the action is. On the left, you draw a digit. In the middle, you watch the neural network process it layer by layer. On the right, you see the result. And further down, the library comparison sections, where three different encryption libraries race each other on the same operations. Everything updated live, nothing is pre-recorded. Okay, let's actually do it. I'm going to draw the number 7 here on this canvas, and I will click run now. So now before anything is processed by the server, this 784 piece of spare value will get encrypted. The server will never see my drawing. It only ever receives log scrambled data and watch the pipeline on screen. Each row is one layer of the neural network, convolutions, activations, pooling, and you can see each other light out as it finishes. This isn't a loading spinner. These are real timing stream back from the server as each layer completes. And the result shows 7, which is correct. And the total time costs 44 seconds. On the right, you can see exactly where the time goes. For the entire inference, the 12th layer of a convolution neural network ran on encrypted data. Yep, so that was one digit, but does it work consistently? Scroll down to the benchmark sections. This shows the result across 10 MNIST test images, all run through the same encrypted pipeline using the OpenFHE. So yes, the result will show you its worked reliably. And now the OpenFHE is just one of the 3 encryption libraries available. So on the library comparison sections, it shows which one is actually fastest. So this is the library comparison. So the 3 libraries, the SEAL in blue and HELIP in purple, OpenFHE in green. So they test on 5 operations. So basically the shorter the bar, the faster it is. So here show the result, and SEAL is the fastest across almost everything. The key generations in 11 milliseconds, while the OpenFHE takes 312 milliseconds. But that's not the full story. The OpenFHE generates all its key upfront, so that cost only happens once, and additions are basically free across all 3, under the 3 milliseconds even for the slowest. The multiplication is where the gap shows the seal at 3 milliseconds, the HE lib at 22 milliseconds, and the open FHE at 28 seconds. And this matters because every activation in our neural network is a multiplication. So seal wins on the speed, but all three libraries work perfectly, and the choice depends on what you need. So to bring it back together, this platform shows you in real time what it actually costs to run AI on data that nobody, not even the server, can read. It runs in your browser, it's deployed on AWS, and the full source code is open on GitHub. So the answer to how slow is homomorphic encryption, it works, it's measurable, and everyone now can play around with this platform to get to know more about homomorphic encryptions. So that basically everything of this platform. Thank you for watching.